Hello and welcome to today's lesson on substitution. To get you started today, there are 8 questions on the board and then there are 3 challenge questions. There is also a hint. We use something to help us remember the something of operations. Please pause the video here to give it a go. I will reveal the answers to the support shortly. So hopefully we remembered that we use BIDMAS to help us remember the order of operations. That should have given us the following answers: 1, 40, 6, 144, 11, 8, 25, and 19. For the challenge, where we were inserting the brackets to make the statement correct, we should have originally put the brackets around the 4 and the 5. We then should have had 2 sets of brackets for question 2, around the 2 and the 3, and around the 4 and the 5. And then in the last question, around the 3 and the 5. For today's lesson, we will be going through substitution. Firstly, looking at substituting integers into simple expressions, then looking at brackets, indices, and fractions. And then the challenge today will be looking at substituting integers into formulae representing real life situations. As a reminder, an integer is just a whole number. This can be a positive or a negative whole number. The reason why this is handy is because engineers substitute negative values into expressions when calculating speeds of trains, especially as they are slowing down. Now, as a quick recap and an opportunity to take some notes, substitution is when we replace a letter with a number, then use BIDMAS to simplify our answer. Example, if n equals 2 and I have the expression 3n squared plus 5, my first step is to substitute n equals 2. That means my new expression is 3 times 2 squared plus 5. Remember, in between that 3 and the n, there is a multiplication sign. I then need to just use BIDMAS. So if I think through what the letters mean, I don't have any brackets. I do have indices, and I know that 2 squared is 4. My next thing I would do is the multiplication. So 3 times 4 is 12, and then 12 plus the 5 gives me a final answer of 17. This is exactly how I expect to see your work set out, making sure you do one step per each line. Now, to give that all a quick go, we're going to try some questions. Obviously, we'd usually use whiteboards for this task, but if you want to just write on your paper or write on a separate piece of paper, that's totally fine. You have 10 seconds to answer each question shown. So hopefully with that question, you got an answer of 3, because I'd have 8 take away 5, which is 3. Here's the next question. Now, thinking carefully about those negatives, if p is minus 7, I have minus 7 plus 4. We did lots of work on our negative numbers at the start of the year, and we spoke about having a cold bath and adding some hot water. So my bath gets warmer, so it becomes minus 3. Here's your next question. With this one, remember when I have 2 things touching, there is a time sign hidden in between them. So this question is actually asking me to do 5 times 2, which is 10. Now, we've spoken before about what that line means. We need to do some division. So for this, I'd have 12 divided by 2, which gives me the answer of 6. For this question, it's important to remember that that power sign means I need to times the number by itself. So for this, I would have 7 times 7, which gives me the answer of 49. Here's your question. This time I have two things to do. When I substitute in, I'd have 8 times 2, which is 16. 16 take away the 1, which gives me the 15 of the answer. Here's your next question. Again, there are two steps I need to do in this question. Firstly, remember it's f squared times 5, not 5 times f, then all squared. So my first step is to do 2 squared, which is 4, and then 5 times 4, which is 20. With this question, I again have two steps. I first need to do the brackets, so I'd have 3 plus 7, which is 10. I then need to do 2 times 10, which is 20. For this question, there are again two steps I need to do. I first need to do 3 times 10 to deal with the 3r, which gives me 30. 30 divided by 5 is then 6. We can also substitute into formulae, and it's exactly the same thing. Remember, a formula is like an expression, it just is equal to another letter. In this example, the formula v equals u plus at can be used to calculate the speed, where u represents the initial speed, a the acceleration, and t the time. An object initially travelling at 10 meters per second accelerates at a rate of 6 meters per second squared for 5 seconds. What is its final speed? My first step, I'm going to write down the formula. I'm then going to substitute in the information they've given me. So they've told me that u is 10, that a is 6, and that t is 5. I'm then going to do exactly what we did before and just simplify that using BIDMAS, which gives me a final answer of 40. That's it for today. The worksheet is attached on Show My Homework and is deciphering a code to reveal a maths joke. Please make sure you show all of your working out on your piece of paper. I look forward to seeing what joke you come up with and what answer you get. There are then 2 challenges practicing substituting into formulae. The answers for all of these will come up tomorrow when you'll have the opportunity to mark your work and then submit it. If you are stuck or have any questions, please email me. Other than that, good luck.